he writes the word data. And it's not as in going out on a data. Sometimes people pronounce it data. Data is a plural form of what word? Does anybody know what the singular form of data is? We don't hear it very often, because we don't usually do it. Data is plural for data, I think. I think it's DAT. It's really neither here nor there, nor is it important. But, what is data? Anybody? Brian, Connor?
Like storage.
No, I'm going to say no on that. You do store data, but data isn't actually the storage. You're talking like a flash drive or something like that, stores data. It's not necessarily the storage, it is just simply,
The information.
yeah, it's just simply information. And in the world we live in, children, data is an unbelievably important part. If you go back 70 years ago and look at what jobs most people had jobs doing probably one of two things. Anybody know what jobs 75, 100 years ago were more like? Alex?
You're either a homemaker or you're a
Like your great-grandparents probably were either, Landon?
or like hunters or something.
Well, hunting, I wouldn't call hunting necessarily a job. 100 years ago to 75, you're kind of getting there, I think. Maggie?
A mother or
We got to the kind of the mother homemaker thing, which is neither here nor there.
and then someone gets gathers food.
Okay, what do we call those people that grow food? Okay, you were probably either a farmer or, come on people, well, not necessarily, not a homemaker, I'm not gonna count that, I mean, I know that's kind of a job, but yeah, okay, let's say there's three, farmer, homemaker, or, come in the Industrial Revolution, come on, you people are fifth graders. You either farmed, were a home, if you're a mom, you were a woman, you probably were a homemaker, good, bad, or otherwise, or you probably worked in a factory, making something, making cars, making things that people used, okay? But today, people, we've completely changed it around. Okay, if you look at most of your parents, now there are some farmers, some homemakers, and some people still work in factories, but a lot of things have changed to jobs that deal with data, with computers, which all computers do is gather, store data. You know, what do you do? What do you do on a computer? You look up information. That's what data is. Okay. How many of your parents work with something with a computer? Okay. By the way, computers when I was your age, nobody, zero. And that's, I know I'm pretty old, but I mean that wasn't that long ago. You talk about 10,000 years the world's been around, computers, you know. How many of your parents are like sell something? Anybody, your parents sell things? What kind of things do they sell?
Like
Even know?
well, not really.
How many of your parents are, how many of you are farmers? Oh, you got a little bit of farming in there, okay. So, you know, the days of the factory jobs, of going there and producing something made with your hands are over. Almost everything we do now deals with trying to gather data and get data out to people and interpret data. I mean, it doesn't do a lot with it. So it's important for us to look at data and see how and today we talk about how do we organize data. Organize it. In other words, having data does us no good if there's not somewhere to organize it. You know, if Taylor was doing a report on Abraham Lincoln, okay, and none of the internet stuff was organized, all the stuff was just in a big pot and you had to look through each piece of information, how long would it take Taylor to find something about Abraham Lincoln? Forever. Do you know how much stuff is on the internet? You could go for years and years and still not find anything on Abraham Lincoln. But it gets organized. You know, how do we get Abraham Lincoln stuff? You guys go and do a Google search or put it in your search engine, you type Abe Lincoln, and it's all organized so that that search engine takes you right to that place where that data is, and you can pick your stuff out of that. Now, when we talk about math, though, we are talking about something that's called statistics. Statistics. Okay, which is just another name for data or number data. In high school or in college, a lot of times they don't call it all statistics, they go with stats, okay? And it is the way you organize, analyze, and display. Organize, analyze, and display it. And today we're looking at how to organize and display. I don't necessarily know that we'll actually analyze it so much, but here's what we're going to do. I want to ask you a question here. What is the question I want to ask? Yeah. Here, we're going to take a little, for example here. We're going to collect some data, and the data I'm going to collect is how many siblings you have in the 5th grade. How many siblings 5th graders have? And let me just go around and quickly ask you how many siblings, that's how many brothers and sisters you have, and this would be total brothers and sisters here. So let's go. Bella, how many? 2. Boom. Kim? 2.
2.
Oh boy, looks like there's a little pattern here.
0.
Oh, the only child, that's only 3.
2.
2.
1.
Ava, 1. Landon.
Logan.
Logan. All right.
1.
1.
1.
1.
1.
1.
0.
2.
2.
2.
2.
Landon, 2.
2.
Row 2.
3.
3.
1.
And 1. Okay. This right here, children, what we just did here is basically called raw data. Why is it raw? Because it's not organized in any way. Okay, you've got all these numbers here. You know, it's really hard to say, you know, if I asked you, you know, how many siblings do most 5th graders have? You kind of have to look at it kind of close, and you know it's between probably 1 and 2, right? But you don't know exactly what it is, or, you know. So we need to, and we want to try to organize this a little bit. And I wish I would have left myself a little bit of room. And we're going to organize it in a couple ways. Let me see if I can copy this. I'm going through the page. Think I can put it right there? Paste. Think I can move it up? Probably not. Oh yes. Okay, and one of the ways we're going to organize it is called, and here's the big one for today, is called a frequency table. So there's number 1 for today. Frequency table. Okay. And by the way, what does frequency mean? Frequency is how often. So if we look at the data we have, we're going to make a table here. First of all, what question did we ask? What is the question on the table, Alex?
How many siblings do 5th graders have?
How many siblings? All right, and our potential answers were what? What is our range of answers? We went from 0 to how many? 3, right? Nobody had 4. Nobody had negative numbers. Now, what you want to do when you do a frequency table is you want to organize it basically using our little tally marks. And you just go through and do this. Okay, here is 1, 2. So you put a little tally mark there. A second 2. A third 2. A 0. A 3. A 2. A 1. A 1. A 1. A 1. Another 1. A 2. A 2. A 2. A 2. A 3. Did I miss one? A 1. Okay. This is a frequency table because it tells you how often a number happened. Okay? And then usually we take frequency tables and we make a bar graph out of it. Okay? And the best way to think about a bar graph on this case is to simply kind of turn the frequency table around. Turn the frequency table on its side. Can anybody read that? I can't. Frequency table. In other words, if I spin this whole thing and I make it look like this, actually, okay, on the bottom is going to be how many siblings we have. 0 siblings, 1 sibling, 2 siblings, 3 siblings. How many siblings? Are you with me? Here's my how many siblings. I turned it like this, so now it's here. And then, how often? What is my frequency? That's this side here. Well, we have to think about how far we go. What? Frequency. It says frequency. Okay. And what is my range of frequencies? Well, we have 2 for 0 all the way up to 8 people said they had 2. So my numbers here have to go all the way up to 8. So I would go, here's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then it's just a matter of shading in your graph there. How many people had 0 siblings? 2. So this gets shaded in all the way up to the 2. That's quite an impressive bar graph there, isn't it? Did I put 2 zeros? Why did I put 2 there? Did I put one of the ones for 2?
I don't know, but only 1 person.
I know. Where did it come from? 1, 2, 3, 4, 5, 6. Yeah, I put one of those. I put one of the ones in my 0 column. So let me erase that. It's an easy fix for those of us not using pen. Anybody using a pen? Never a good idea to use pen. Shh. See, you're lucky day. So now I just have to erase my graph. But I can't get, why won't that piece come off there?
Now look like a space. Now it says space.
No, it doesn't. The other way to erase, there's always more than one way to skin a cat. How else can I erase? I can draw in white. That's spiffy. Okay, so there's my 1 person said 0. What did I do? Frequency? What? Okay. Yeah, you can change. Mio's just asking the question, you know, do I have to do every one? No, I don't. I could make it, I could go 0, 2, 4, 6, 8. However you want, as long as you get it in there. I just did every one to see it. How many people said 1 person? 6, so that gets colored all the way up to the 6. So you have to color all of this in. How many people said 2? That goes all the way to the top. And I'm sure your graph looks much better than mine.
No.
And then how many people said 3? Only 2. Okay. So once we do this, people, you know, what's easier when you look at it, if I ask you some questions about siblings, is it easier for you to look at this graph and say, oh, look at all the people that had 2 siblings, or is it easier for you to look at all the raw data where all the numbers are all jumbled up? Okay, the reason we take it and we put it in graph form is that it makes it in picture form, and we always see better in picture form than we do just with numbers all scattered about right there. You know, so you could tell me right away, boom, how many people had 2 siblings? You just look at 2 and it goes up to 8. How many people had 1? You look here and you get 6. You know, if you didn't know that, you'd have to go, oh, I have to count here. Let's see, 1, 2, and you can get all confused. So That is the reason we try to organize data so that you can use it, more efficiently and more effectively. This is the part where you ooh and ah. Now, one other way, that's very nice. Did you practice that?
No.
One other way,
It's not
yeah, natural talent. Another way that we can organize it is with what we call a line plot. And if you want to just jot this down here, what is a line plot? Really, it's kind of like, it's a lot like the frequency table, but it's a different way to do it.
Is that a different page?
Yeah, well, you can make it, you can put it under this, under data, that's fine. Okay. A line plot looks like this. You first of all draw a line. Interesting. Okay. And then on the line, you put the numbers of what your answers could be. My answers, I go 0, 1, 2, and 3. And then instead of making tally marks like we did with the table, you put an X for every answer they give. For example, here's a 2, so I put an X above the 2. A second 2, so I put a second X above the 2. A third 2, you put a third X. You put an X above the 0, an X above the 3, an X above the 2, an X above the 1. How many ones do I have there? 6 in a row, 5 in a row. 2, 3, 4, 5. Another 2. Oh, 3 more 2s. 1, 2, 3. Another 3. And another 1. And this would be your line plot. And again, actually it looks a lot like a graph, doesn't it now? I mean, if you just color in the circles there. But it's easy to see which one had the most, which one had the fewest. It's easy to see that 3 only had 2 and 0 had 1. It's another way to organize fair data there. You got that? Because we got a couple other things to talk about. On this same map here, we have what's called a cluster. And you probably know what a cluster is. What do you suppose a cluster is when it refers to data? Meg?
A group of information.
Yeah, a group that's kind of close together. A group close together. If you were looking at this data here, where would you say the cluster is? What would be the cluster? Where does it seem like there's a whole bunch of things there? Sammy? 2s, and I would put this, see this is kind of one big cluster because there's a lot more in the 1s and 2s than there is in the 3s and the 0s. You're looking for not just one specific role, but a group where they all kind of pack together. It'd be a little like if I put all your grades on a quiz on the board, and the cluster would be what most people got, not just one, but what almost most everybody got. In addition to that, we have what's called an outlier. Maybe that sounds familiar. What do you think an outlier is? It sounds just like what it is there, Mia. Okay, it's like a number. Let's just put that instead of what I was going to write. I was going to write Daytona. A number way outside the rest. Okay. Now, if you look at this, what we did here, there's really not an outlier because 3 is outside the cluster, but it's not that far outside. An outlier would have been had somebody in here maybe had 7 brothers and sisters. Okay, that 7 would be way outside what's normal, and we call that an outlier. And the reason you want to think about outliers is because sometimes outliers can mess up your data. Okay, because it'd be a lot like if I gave a test and everybody got like an A, and one person got like a 0. Okay, and then I took the average for the class. Okay, what that 1 0 does is it takes all those other people's scores and drags them down disproportionately. Okay, so you really, when you think about data, you look for outliers and you don't really include them because a lot of times there's somebody way outside that really messes up everything else if you put it in with the group. So you have to watch out for that. Oh, we got so much stuff to do here. Good, good, good. All right, now more notes. You should be happy for more notes because more notes means what?
More
brains.
Less homework.
But it needs more brains too.
Oh, it does mean more brains.
More
brains. Write down these numbers, please. Well, no. Let's use the same numbers we had. Can I still paste them up here?
Yeah.
A lot of times when we talk about data, we also talk about the mode, the median, and the range. The mode, the median, and the range. All good numbers to know. But before you talk about those, or think about those, the first thing you have to do is arrange your data from least to greatest. Okay, in other words, I should be looking at my line plot here because it helped me, but it's on a different page, so I won't. What I need to do is take all of my numbers and write them down from smallest to biggest. So it would look like this. What I had 1 0. How many ones? 1, 2, 3, 4, 5, 6 ones. How many twos? 8. 2, 2, 2, 2, 2, 2, 1, 2, 3, 4, 5, 6, 7, 8, and then I had 2 3s. And you can use a line plot actually to do this with. You don't need to do it like I, but I'm going to do it like this so you can kind of see it. And these three are really easy. The mode, okay, the mode, anybody know what that means? Let me give you a clue. If you forget it, just think of the first 2 letters in mode. Mo, and then add an ST to it. It's the number that appears the most. Okay, if you look at our data here, what is the mode of these numbers? Which number appears the most? Alex, 2. So this one, the mode is 2 because it appears the most. Now what if 2 numbers appear the most? Then it has 2 modes. We call it bimodal or whatever. If no number repeats or appears the most, then it doesn't have a mode. How about the median? If you hear the word median, what does it make you think? Anybody? Roads have medians. Madison's going to take a stab? Madison is not taking a stab. Brooke is going to take a stab? Exactly, and that's the word you think about, in the middle. Now, what number's in the middle here? Well, now this one takes a little bit of work because you're going to have to count how many numbers you have and see what number is halfway between all of them. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 numbers. And it's good to have an odd number because there's an exact middle to an odd number. Okay, what is the exact middle of 17?
2.
This is not easy. Kaylin, what do you think?
13 and a half.
What's that?
13.
Not quite. Halfway. Halfway. If you have 17 numbers, there's one number that fits exactly in the middle, where there's the same numbers on the left side as the same numbers on the right side. Think about it a little bit. Kaylee?
Then, 9.
Let's check it out. 1, 2, 3, 4, 5, 6, 7, 8. The 9th number is exactly in the middle. Why? Because there are 8 numbers on this side of it, and there are 8 numbers on that side of it. So the 9th number, if you have 17, is the middle. So the median of this number just happens to be 2. Sometimes they're the same, sometimes not. What do you say? What if it's an even number?
We have 2.
And I don't know if they probably won't give you this as fifth graders, but if it's an even number, let's say there was another number here, we had another 3. Okay, that would mean these two numbers fall in the middle. You have to take actually the average of those two numbers, which is pretty easy to take the average of 2 and 2 because it's 2. The middle of 2 and 2 is 2. But I don't think they'll give that to you now, and let's not worry about it. Let me get all this stuff out of here, take that 3 away. Now, the range. Anybody know what the range of the numbers is? And it is, Maggie, just? Are you gonna?
Around the average.
No, not exactly, Ryan. Is that what you're gonna say? The range is the difference, which means it's a subtraction problem. It's the difference between the small and the big. It's the difference between the smallest and the biggest. In other words, my numbers range from 0 all the way to 3. So it is 3 minus 0. It is a range of just 3. Because, okay, you go all the way from Caitlin having no siblings to Cameron and who else had 3? And Leah having 3. That's the range, the difference in those from the smallest to the biggest. Man, we're learning a lot today. Oh, we don't have much time.